Now that we've talked about the Java countdown latch barrier synchronizer, it's time to turn our attention to the structure and functionality of the Java CyclicBarrier synchronizer. So in this lesson, we're going to talk about the CyclicBarrier, starting with a discussion of its structure and functionality. So the CyclicBarrier implements another Java barrier synchronizer. This synchronizer allows a set of threads to wait for each other to reach a common barrier point. And for some odd reason, the mechanisms are referred to as parties. And so the parties that are involved here are basically threads. One human known use of the barrier synchronizer, which I think I alluded to when we gave an overview a little earlier in a previous lesson, was that humans in an assembly line, groups of workers in an assembly line, could be thought about as implementing the CyclicBarrier mechanism, where the automobiles come up to them, a group does their thing, they put tires on or add the transmission or deal with windows or whatever they have to do, upholstery or other things for the car. And then once that group is done, then the car moves down the line, the next car comes up, and they all start the process over again. So you can kind of think of that as sort of cyclic, where parties, threads, people, workers, and so on take turns working on something in phases. The CyclicBarrier is very well suited for cyclic entry and or exit barriers. So if you recall, those were the three different categories that we had talked about when we introduced the concept of barrier synchronizers earlier. And so you get all three of these with cyclic barriers. Entry barriers cyclic barriers can also be reset manually at any point, although that triggers something called a broken barrier exception to indicate to the waiting threads that they didn't get through the process in the normal path, but they did it through something being reset. In contrast, the Java countdown latch that we had talked about last time does not enable the barrier to be reset. Basically, you just wait till you count down, and you have to, essentially Java countdown latches are one-shot entities as opposed to cyclic entities. As with countdown latches, a CyclicBarrier does not, in fact, implement any interface. It just defines the methods that it defines. Likewise, the CyclicBarrier, unlike the countdown latch, does not apply the bridge pattern. So they don't have any of the same familiar structures that we've seen before with some of the other synchronizer frameworks in Java. It also does not use the abstract queued synchronizer framework. And this, of course, is in contrast to reentrant lock and semaphore and condition and countdown latch and so on and so forth. Instead, what the CyclicBarrier does is it defines a number of fields that it uses to provide the implementation of cyclic barriers. And if you take a look here, here's a little snippet of code from the Java class library that illustrates how this works. You can actually, if you want to look at the code, it's all available here at this link. It's actually really fun to look at once you understand what reentrant lock is, once you understand what a condition object is, you'll have a pretty easy time understanding how the CyclicBarrier actually works under the hood. So one thing it has, as you can see, is it's got a lock, a reentrant lock that's used to protect all the shared mutable state in the critical sections that can be accessed concurrently. It has a condition object that's used by all the waiting threads, or the parties as they call them, to wait upon until it's so-called tripped. Funny name, you're going to trip the barrier. It has a field that keeps track of the total number of parties, and this value is set initially by the constructor of CyclicBarrier, which we'll talk about in a moment. And so that's the number that we're waiting for. And then it also keeps track of the number of parties that haven't yet called a wait. So this count obviously will be initially set to the total number of parties, and then it's decremented by 1 every time a thread or a party calls a wait. And then it also has another field that's called the barrier action. And this is an optional field. You don't have to use it. But what it's used for is when the barrier is tripped, in other words, after all the parties arrive and call a wait on it, then if you've provided this barrier action or barrier command, as it's called here, then that action will be called and it'll get a chance to run before all the parties start the next phase of the cycle. And it's a runnable, so of course it's got a run hook method that can be used to do something. So that's the end of the overview of the structure and the functionality of Java CyclicBarrier. It's a really, really cool class, and for problems that require multiple phases, it really helps to save the day. One thing it also is restricted in terms of, which we'll talk about when we get to the next part of the lesson, is you have to have a fixed number of threads. It doesn't handle a variable number of threads.